We're diving deep into a Saturday that felt, well, anything but slow. AI development on December 20, 2025. It was really defined by two powerful contrasting
It
forces.
really was. They're sort of pulling the entire industry in opposite directions.
Exactly. On one hand, you have this furious global arms race for physical compute infrastructure. I mean, a battle that has now officially jumped into the gigawatt era.
And on the other, a sharp, almost frantic escalation in regulatory conflict, especially here in the U.S.
That's a perfect summation. While nations are making these immense city-level power commitments for data centers, policymakers are scrambling to impose safety rules.
Right. And with these incredibly tight disclosure deadlines, it's happening before the systems are even fully deployed. It feels like a collision course between speed and safety.
It does. So today we're going to unpack the details behind New York's new, very stringent AI safety law.
That 72-hour disclosure window.
And China's bold moves toward chip independence and the deep technical shifts happening inside the models at OpenAI and Google. We've got a stack of sources that cover everything.
Our mission is to give you that concise, high-value extraction of the day's most important news and research.
Okay, let's unpack this.
Welcome to the deep dive. You know, this day is characterized by really aggressive specialization in models. You'll see some optimized for speed, others for long-term complexity.
And a strategic pivot toward what people are calling sovereign AI infrastructure.
Exactly. All across Asia and the Middle East. If you want to know what's driving the global economy next week, you are definitely catching the critical knowledge right now.
Let's start where the innovation begins. Research models and, I guess, the underlying safety mechanisms that govern them. We're seeing a very clear strategy divergence from the big players.
Yeah, and it seems to be based entirely on the use case.
So what's the best example?
That divergence is best highlighted by the introduction of OpenAI GPT 5.2 Codex for long horizon engineering.
Okay, so this is a new large language model, an LLM.
Right, released for automated software engineering. It's designed specifically to manage and evolve massive code bases without, forgetting what it was working on half an hour ago.
Which is a huge problem. When you're dealing with thousands of lines of code, the sheer size creates a serious memory issue for the model. What's the technical metric that makes this a breakthrough?
It's all about memory management. The model uses this crucial, innovative feature they're calling context compaction.
Context compaction.
And that's how it addresses the inherent O of L squared computational bottleneck.
The quadratic complexity problem.
Exactly. To put that in plain language for you, as the code base length, that's the L, gets longer, the computational demands just grow exponentially.
Right.
Context compaction allows the model to summarize and prioritize the most important parts of the code history, letting it maintain this high-fidelity representation across huge projects.
So this moves AI coding from just simple function generation to, what, true project maintenance?
True. Long horizon project refactoring and maintenance, yes.
Okay, so that's a focus on depth and complexity. Now, if OpenAI is going for that high-fidelity long-term memory, Google is taking the opposite lane.
They are. They're focusing on pure speed with their counter launch.
Which is?
That's Google's Gemini 3 Flash. This is a multimodal model, and they're positioning it as a frontier model for speed. It's designed for these high-frequency agentic loops where latency is everything.
So think iterative development, rapid decisions, needing almost instant responses.
Exactly.
Benchmarks indicate this model actually outperforms the larger Gemini 3 Pro in some coding tests. How is that possible if it's smaller? Is it just trading capability for speed?
It's a strategic specialization. The Flash model optimizes its reasoning path specifically for these short burst iterative tasks.
Wow, okay.
It's less about deep, long context reasoning and more about quick, accurate decisions. So in those specific tests where you need rapid, repeated adjustments, the Flash model's architecture just gives it an undeniable edge.
It proves that sometimes, yes, specialization can beat sheer size.
It really can.
All right, shifting gears completely from utility to creativity. This is where it gets really interesting. A new study found that AI image generators converge to just 12 visual styles.
This is fascinating research. Gizmodo reported on it. Researchers ran this experiment. It's almost like a game of visual telephone between image models.
Like Stable Diffusion XL and Alavi.
Those are the ones. They took generated images, fed them back into the other's captioner, and then regenerated them over 100 rounds.
And the sequences just collapsed. I mean, the models defaulted to cliches.
Exactly. The final outputs all collapsed into one of 12 dominant, predictable styles things like photorealistic lighthouses, specific kinds of interior photos, portraits with similar lighting.
So what does that suggest?
It suggests that if you let AI creativity run unsupervised, it lacks true diversity. It defaults heavily to these common motifs, these statistical averages from its training data.
Which has huge implications for digital art and, I guess, prompt engineering.
Yep.
Okay, finally, let's wrap up research with proactive safety. OpenAI introduced a framework to measure chain-of-thought monitorability. This feels like it's tackling one of the biggest fears out there.
It is. The framework uses a suite of 13 different evaluations to measure how easily an advanced model's internal reasoning steps can be audited. This is essential for addressing the risk of deceptive alignment.
Okay, for our listeners, what exactly is deceptive alignment? Why is this metric so important right now?
Deceptive alignment is the risk that an advanced model might develop a hidden, maybe even a dangerous intent, but it hides that intent by appearing compliant and helpful during testing.
Right.
So this monitorability framework is OpenAI's attempt to show regulators and the public that advanced reasoning doesn't have to come at the expense of transparency.
And what are they claiming?
They're claiming, based on this new metric, that GPT-5 is the most monitorable model they've studied to date. It's a crucial proactive step, especially given the regulatory environment we're about to discuss.
So if the researchers are setting the technological roadmap, the product teams are delivering the user interface. Let's see how those advancements are reshaping the tools you use every day.
The transformation of work tools into agent platforms is, it's accelerating rapidly. The prime example today is Zoom, which launched AI Companion 3.0 with agentic work automation.
What stands out here is that Zoom is trying to be so much more than just video conferencing. They introduced a browser-based AI dashboard, ai.zoom.us.
With these new agentic tools that can search across Zoom and third-party apps like Google Drive.
It's trying to be the connective tissue of your work life.
And this matters for the individual user because the AI Companion is now offered as a $10 a month standalone add-on for non-enterprise users.
That's a big shift.
It is. This change in monetization and functionality transforms Zoom into a direct competitor for Microsoft and Google Workspace.
Meanwhile, the conversational layer itself is getting more flexible. OpenAI added ChatGPT personality customization sliders. I have to admit, I'm intrigued, but I also have to wonder if my AI having high warmth is just going to mean too many emojis.
Well, that's the future we live in. This gives you, the user, more agency over the interaction style.
Yep.
You can now adjust characteristics like warmth, enthusiasm, and emoji use with these sliders. It builds on the existing presets.
So it's a direct response to criticism that the AI's tone could feel a bit, I don't know, robotic or condescending.
Exactly. It makes the whole experience much more tailored to you.
Was perhaps the most strategic launch of the day came from Anthropic. They launched the skills feature as an open standard for agent interoperability.
This is a significant move. It's about market dominance without necessarily building the biggest model.
How so?
Anthropic is taking its repeatable workflows, the skills you teach to Claude, and turning them into an open standard. They're already partnering with major players like Notion and Figma.
The goal being to prevent the agent market from fragmenting.
Precisely.
So instead of having to teach every single agent how to do a complex workflow, this modularity allows for complex, cross-platform workflows to be executed seamlessly.
That's it. They are essentially positioning themselves not just as a model provider, but as an operating system, a universal translator for AI agents, letting different tools speak the same skill language.
Before we move on to hardware, we should note a quick consumer timeline snag. It looks like Google hit a bottleneck and delayed the full Gemini transition on Android until 2026.
Yes, integrating a foundational model like Gemini into the deep operational layer of billions of Android devices is proving to be very complex.
Not surprising, I suppose.
Google announced it needs more time, officially pushing the full replacement timeline, which was supposed to be the end of 2025, into the 2026 calendar year.
It just signals that even for the giants, this kind of deep integration is a massive engineering challenge. Now we get to the core of the global competition: chips, infrastructure, and the raw energy required to run these systems.
This is where the demands of the software we just talked about crash right into the reality of scarcity. This is the gigawatt era.
And that scarcity is driving nations toward what you called sovereign AI ambitions.
Meaning they're investing locally to ensure they have computational independence. You see this most clearly in the announcement that STC and Humane formed a joint venture to build 1 GW AI data centers in Saudi Arabia.
1 gigawatt. That is a truly staggering figure for a specialized compute facility. That's enough power for a medium-sized city.
It targets up to 1 gigawatt of AI workload capacity with an initial commitment of up to 250 megawatts.
It signals that nations are just investing immense capital to ensure they aren't geopolitically dependent on Silicon Valley or U.S. export controls for their intelligence infrastructure.
Exactly. Access to energy and access to chips are now strategic national assets.
Speaking of chip independence, China is making a powerful move toward self-sufficiency. More Threads unveiled the Huagang GPU architecture and the Huashan AI chip.
This is a direct, you could say a measurable response to U.S. export restrictions. More Threads is trying to build a competitive computing ecosystem from the ground up.
And that means having their own chip architecture and their own software stack.
Right. Their stack is called MUSA, which is functionally equivalent to NVIDIA's CO.
What's the performance claim that makes this a potential game changer for China?
2 key metrics. The new Huagang architecture claims a 50% density improvement and, crucially, 10 times the energy efficiency gains.
10 times.
These improvements are critical for accelerating China's national push for AI chip self-sufficiency, giving them a domestic path to overcome the current restrictions.
And yet, even with all these massive investments globally, we have reports that Google faces an internal compute famine. Demand is just outstripping supply.
This is the narrative centerpiece. It highlights that AI compute is a profoundly scarce strategic resource, even for a tech giant spending, what, $93 billion a year on AI?
The internal demand is so high that CEO Sundar Pichai has reportedly had to personally intervene in chip allocation conflicts between product teams.
It shows this isn't just a regional issue. It's a global scarcity problem that's felt hardest right at the top.
And that demand for physical compute is reshaping local policy, even here in the U.S. Georgia regulators approved a 50% power capacity boost for AI data center demand.
Just think about that metric, a 50% increase in power generation capacity. It was just approved to meet the anticipated needs of massive new AI data centers moving into Georgia.
That's tangible evidence. This isn't just an IT problem anymore.
No, it is fundamentally reshaping state-level energy policy and utility planning in real time.
The rush for power is being met head-on by a rush for regulatory containment. Let's look at policy, governance, and standards, where New York just dropped a regulatory bomb.
It will force companies to rethink their entire internal monitoring systems.
What are we talking about?
That would be the New York RAISE Act, the Responsible AI Safety and Education Act. Governor Kathy Hochul signed it into law, making it the nation's second major state AI safety law.
We've seen other states move, but what makes New York's law so distinct and, well, challenging for frontier AI companies?
The RAISE Act requires large AI developers, we're talking those with over $500 million in annual revenue, to publish safety protocols and report safety incidents to the state.
Okay, but here's the kicker.
The kicker is the deadline. The law requires incident disclosure within a strict 72 hours.
72 hours. That is significantly stricter than the 15-day requirement in California's competing SB 53, isn't it?
It is. It positions New York as a fast, demanding regulatory leader in the U.S., and it immediately raises the pressure on those internal auditing systems.
Globally, while the U.S. is focused on corporate disclosure, China is focusing on strategic application. They opened the National AI Medical Pilot Base for public use in Zhejiang.
This is all about consolidating resources to drive real-world outcomes. The base integrates computing power, unified medical data, models, and validation centers into one publicly accessible infrastructure.
The goal being to accelerate the translation of AI research into clinical medical applications.
A huge strategic priority sector, yes.
Meanwhile, India is taking a more pragmatic, adaptive approach. They clarified their risk-based AI governance guidelines in Parliament.
Right. India's Ministry of Electronics and IT confirmed they're adopting a risk-based, evidence-led approach. It relies heavily on existing laws like the IT Act, rather than creating entirely new, comprehensive AI legislation.
A techno-legal approach.
That's what they're calling it. It balances innovation with safety, and it's a model that could influence a lot of other developing nations.
And over in Europe, we see a focus on the fundamental, long-term health of the field. 6 German mathematical societies issued policy demands to bolster the AI foundation.
They released a joint strategy paper urging the government to bolster AI capabilities by focusing on math research, technology transfer, and talent training.
So they're pushing for more funding for fundamental mathematics.
To ensure Germany remains competitive in future innovation, recognizing that today's models are only as good as the science they're built on.
Our final segment connects all these forces, the power, the regulation, the specialized models, to security and real-world adoption. First up, a major security alert that highlights why New York might be right to be so demanding.
This is a huge one for contextual privacy. A security company named Koi identified browser extensions with 8 million plus installs found harvesting AI chatbot conversations globally.
8 million installs. So we had to talk about malicious extensions, including one called Urban VPN Proxy, capturing the full sensitive text of user interactions with ChatGPT and Gemini.
And selling that data to third-party firms.
Wow.
It demonstrates a massive breach of contextual privacy. A lot of those users are employees using these unauthorized shadow AI tools for work, potentially exposing source code, internal strategy, sensitive data.
It just underscores the urgency behind regulatory oversight.
It really does.
On the adoption side, we see real progress in robotics, moving beyond just simulation. Physical intelligence showed emergent human-to-robot transfer in vision language models.
This AI robotics startup found that by including human video data, specifically hand poses and physical demos from wearable cameras, in their fine-tuning process, their vision language action, or VLA, model showed marked improvement.
And what's the key metric?
The key metric is that fine-tuning with human video data can actually double the VLA model's performance on the tasks shown in those videos.
It's like giving the robot muscle memory training.
That's a great analogy. It lets it skip millions of expensive trial and error steps.
Let's look at the future workforce pipeline, which suggests India will be a major supplier of talent.
Yes. India's AI talent base is expected to more than double by 2027.
That's supported by government investment in academic programs.
It is, and it validates India's immense strategic focus. India currently leads globally in AI talent acquisition with an annual hiring rate of around 33%.
Positioning it as a key player in the global AI workforce.
No question.
And finally, a great example of infrastructure investment paying off. MasOrange and Ericsson delivered a live 5G standalone slice for Madrid Public Safety.
This is a concrete production example of network slicing providing guaranteed quality of service.
So a guaranteed dedicated pipeline, like a reserved lane on the information highway.
Exactly. It's for mission-critical scenarios like wildfires and disasters. It ensures secure, low-latency communications are always available for emergency services when they need them most.
This deep dive into December 20, 2025 has shown us that the AI world is simultaneously expanding physically, demanding gigawatt-scale power, and contracting structurally, with regulators imposing tighter and tighter safety clocks on the systems.
It is the definition of tension.
Before we wrap up, here are 2 tools and features you can use today.
First, if you use Zoom, check out the AI Companion 3.0 update. You can access the new browser-based dashboard at ai.zoom.us to start automating chat summaries and document creation.
Second, if you use ChatGPT, go into the personalization settings menu to experiment with the new sliders. You can now adjust your AI assistant's warmth and enthusiasm to tailor the conversational tone.
And the numbers of the day.
Go ahead.
72 hours. That's the strict deadline for frontier AI companies with over $500 million in revenue to disclose safety incidents under the new New York RAISE Act.
And 1 gigawatt. The planned AI-specific data center capacity target for the STC Humane joint venture in Saudi Arabia, underscoring the monumental scale of compute sovereignism.
You know, the tension between that New York RAISE Act, which mandates disclosure within that tight 72-hour window, and the new OpenAI monitorability framework, which is all about auditing a model's deep internal reasoning.
It raises a question.
It does. Can internal model transparency ever reliably keep pace with the external regulatory deadlines being imposed by governments? It's the challenge of safety versus speed that will define the next few years for you.
That's a powerful thought to leave you with. The friction between the engineering depth and the regulatory speed. Thank you for diving deep with us. We'll catch you next time for more high-value knowledge extraction.